Welcome to all. Today we are going to start Mathematics of Class 9 Standard. Today we will start chapter number 2, Polynomials. As the chapter name is Polynomial, we should know what is the meaning of polynomial. In your previous class, you have done algebraic expressions. Please try to recall what are algebraic expressions. Algebraic expressions are the expressions which consist of variables and constants, and these variables and constants are linked together by some algebraic operations like addition or subtraction. Same way, polynomials are also algebraic expressions only. The only difference between algebraic expressions and polynomials are that in algebraic expressions, the power of the variables can be positive or negative. But in case of polynomials, the power of the variable is always positive. Now let's see here. It is written, it is an algebraic expression consisting of variables, constants, and algebraic operations like addition, subtraction, and the variables are raised to the power of whole number. Now here you can see it is written, variables are raised to the power of whole number. That means in case of polynomial, the variable will have a power which is a whole number. Whole numbers means the numbers which starts from 0. That means the power of the variable can be 0, 1, 2, 3 and so on. It cannot be negative. Whole numbers are all positive numbers including 0. Now let's see this example. The given expression is x cubed plus x square minus 4x plus 7. Here variable is x. Let's see the power of the variable x. Here power of the variable x is 3. Here power is 2. Here power is 1. So we can see that all the powers of the variable x are positive. That means no power is negative. That means the given expression is a polynomial. Now we will see in this polynomial 7 is without any variable. That means 7 is a constant. The term variables and constants also we have done in our earlier classes. Variables are the value of something which keeps on changing and constants are fixed value. Now next point is, if the variable in the polynomial is x, we can denote it as px or qx. Now whenever we have to write the value of any polynomial, we will write it as px or qx and it depends on the variable in the polynomial. If the variable is x, we can write it as px. If the variable is y, we can denote it as py. In a polynomial, exponent should be a whole number. This already we have done. For any algebraic expression to be a polynomial, the condition is the exponent should be a whole number. Whole number means again the value should be 0, 1, 2, 3 and so on. All the positive values. Value of the exponent cannot be negative. Now here question is y raised to power 3 plus 1 upon y minus 2 a polynomial? Now we have to find out whether the given expression is a polynomial or not. Now to find out this, what we will do, we will see all the terms of this algebraic expressions and we will see the exponent of each term. If all the exponents are positive, that means the given algebraic expression is a polynomial. But if even one exponent is negative, that means the given expression is not a polynomial. Now let's see this algebraic expression. In this algebraic expression, first term is y cube. Now in this y cube, variable is y and we will see the power of the variable is 3 and 3 is the whole number and it is a positive. Now we will see the second term. Second term is 1 upon y. 1 upon y we can write it as y raised to power minus 1. Now here the exponent is minus 1, that means negative. But we have done that the exponent should be a whole number. Negative numbers are not whole numbers. Now let's see the third term. Our third term is 2, minus 2. So 2 is here without any variable. So when there is nothing, that is it is 2 into 1. So in place of 1, we can write down y raised to power 0. We have done in earlier class in algebraic identity is that any number a raised to power 0 is equals to 1. So here we can write it as 2 into y raised to power 0. Now in this variable y, if we will see the value of the exponent, it is 0, and 0 is a whole number. So if we will see all the three terms, here power is positive, here power is positive, but in this second term power is negative. That means it is not a whole number. That means the given polynomial, the given algebraic expression is not a polynomial. Now let's take another example of polynomial. Here our polynomial is 4x cubed minus 7x square plus 15x minus 9. In this polynomial, variable is x, so we have denoted it as px. If the variable is y, we can denote it as py. This we have already discussed. Now, as the algebraic expressions, polynomials are also made up of terms. If we will see this polynomial, total number of terms are 4. So, the terms of in this polynomial are 4x cubed minus 7x square plus 15x and minus 9. The term without any variable is called constant. So total number of terms in this given polynomial is 4. Now terms are made up of variables and coefficient. If we will see the first term, the coefficient of this first term is 4. Coefficient in second term is minus 7. Coefficient in third term is 50. So polynomials can be made up of 1 term, 2 term, 10 terms, 15 terms, or infinite number of terms. So it's written a polynomial can have infinite number of terms. Now let's discuss the types of polynomials. A polynomial with only one term is called monomial. A polynomial with 2 terms are called binomial, and a polynomial with 3 terms are called trinomial. That means if in a polynomial there are only 2 terms, so we can tell it as binomial. If in a polynomial there are 3 terms, so it will be a trinomial. Now our next topic is degree of the polynomial. Now it is written the highest power of the variable in a polynomial is called the degree of the polynomial. Now highest power is, this term is very important. Now we know this is a polynomial. In this polynomial, variable is x and all the powers are positive. That means whole number. That means this algebraic expression is a polynomial. Now if we want to find out the degree of this polynomial, so we have to see the highest power of the variable. Now if we will see here, the power of the variable is 8. Here power of the variable is 6 and here it is 3. Now out of 8, 6 and 3, which number is the highest number? That is 8. That means the degree of the given polynomial is 8. Here variable is x and the highest power is 8. So degree of the given polynomial is 8. So what we have to do to find out the degree of the polynomial? We have to just observe the variable and its power. The highest power of the variable is the degree of the given polynomial. A polynomial in one variable x of degree n is of the form an x raised to power n plus an minus 1 x raised to power n minus 1 plus an minus 2 x raised to power n minus 2 plus so on a1 x raised to power 1 plus a0, where an minus 1, an minus 2, so on a2, a1, a0, these all are the constants, and an, this is very important, an should not be equals to 0. If all the constants are equals to 0, constants means an is equals to an minus 1 or an minus 2 or a2, a1, a0, all are 0, then we will get a 0 polynomial. Constant polynomials. These are the polynomials without any variable. Now here example, I have written 2, 4 or minus 5. Let's first consider 2. Now 2 is a polynomial. It consists of one term only, so it is a monomial. Now in this term, variable is nothing. No variable is there. That means it is a constant polynomial. So any polynomial without any variable is called constant polynomial. So 2 is a constant polynomial. 5 also without variable is a constant polynomial. minus 5 also without variable. So it is a constant polynomial. The degree of a non-zero constant polynomial is 0. Now let's discuss this. We know degree means the highest power of the variable. Now in case of non-zero constant polynomial, non-zero means the polynomial should have some value. For example, 2. It is a constant polynomial because it is not 0. It is a constant polynomial without any variable. So when there is no variable, I can write any variable raised to power 0. Suppose I am writing y and raised to power 0. We know the algebraic identity is that any number a raised to power 0 is equals to 1. So in place of 1, I can write y raised to power 0. So it is a constant polynomial only. And if I want to find out the degree of this constant polynomial, so I have to see the value of the exponent or the highest value of the exponent. Now here only one variable and its exponent value is 0. That means the degree of this polynomial is 0. So in general we can say the degree of a non-zero constant polynomial is 0. The constant polynomial 0 is called the zero polynomial. Suppose I will say we have a constant polynomial 0. If polynomial is not 0, I can write it as 1. So it is a constant polynomial. If I will write 3, it is a constant polynomial. But if I will write 0, so it is a zero polynomial. The degree of a zero polynomial is not defined. Now next topic is types of polynomials. Now first is linear polynomial. A polynomial of degree 1 is called a linear polynomial. So what we have to do, we will see the polynomial and then we will check the degree of the polynomial. If the degree of the polynomial is 1, that means the given polynomial is a linear polynomial. For example, here it is written 2y plus 4. Now we will see the variable is y and power of the variable is 1. That means the degree of the variable is 1. That means it is a linear polynomial. In second example, z minus 21. Variable is only one z and the power of the variable is 1. So it is the degree of the polynomial and its degree is 1. So it is a linear polynomial. Next is quadratic polynomial. Quadratic polynomial is a polynomial of degree 2. For example, x square plus 5. You will see the variable here, variable is x and the power of the variable is 2. No other variable in this polynomial, that means it is the highest exponent of the variable. That means its degree is 2, so it is a quadratic polynomial. And next polynomial, it is y square minus 3y. Now here variable is y, now power of the variable is 2, here power of the variable is 1, highest power of the variable is here 2. That means degree of the polynomial is 2, so it is a quadratic polynomial. Third is cubic polynomial. A polynomial of degree 3 is called a cubic polynomial. Now let's see this polynomial. 3x cubed minus 8x plus 4. Now here variable is x. Now let's see the power of the variables. Here power of the variable is 3. Here power of the variable is 1. So what is the maximum value of the power? That is 3. That means degree of the polynomial is 3. So it is a cubic polynomial. Now let's start exercise 2.1. Question number 1 is, which of the following expressions are polynomials in one variable and which are not? State reasons for your answer. So basically what we have to do, we have to find out whether the given expression is a polynomial or not. If it is a polynomial, then we have to find out it is a polynomial in one variable or not. So basically we have to find out two things and we have to give the reason also, whether the given expression is a polynomial or not. We have to give reason for each. Now let's see first part. First part is 4x square minus 3x plus 7. Now we will see the first part. Here the variable is x and the power of variables are 2, 1 and 0. So all the powers are positive. That means all the powers are whole number. That means it is a polynomial. And if we will see the variable is only x, that means it is a polynomial in one variable. Now same way, question number 2, part 2, it is y square plus under root 2. Now here we will see variable is only 1 and the power of the variable is 2. So variable is y and power of the variable 2. 2 is a whole number, so it is a polynomial in one variable. Third part is 3 under root t plus t under root 2. Now here we will see the variable is t, that means only one variable. Now we will find out the power of the variable. Now it is written square root of t. Square root of t means t raised to power 1 by 2. Here it is written power of the variables are 1 upon 2, which is not a whole number, and in second term power of the variable is 1. So here it is whole number. This is correct. But here it is 1 by 2. It is a fraction. But our condition for an algebraic expression to be a polynomial, that power should be a whole number. But here power is 1 upon 2. So the given polynomial is not a polynomial. Now let's see fourth part. A fourth part is y plus 2 upon y. Now if we will see here, again variable is y. Only one variable. Here also y and here also y. Now we have to find out the power of the variable. Now in the first term, power of the variable is 1. But in the second term, it is 1 upon y. We know the algebraic identity that 1 upon a is equals to a raised to power minus 1. So the power is minus 1. Same way here. 2 upon y, we can write it as 2 multiplied by y raised to power minus 1. So here power is 1, but in second term power is minus 1. Now again minus 1 is not a whole number. So the given algebraic expression is not a polynomial. Now last part, it is given x raised to power 10 plus y raised to power 3 plus t raised to power 15. Now let's see first the variables. Now if you will see here, variables are x, y and t. So here three variables are there. One is x, one is y and t. Now let's see the powers. The power of the variable x is 10, power of the variable y is 3, and power of the variable t is 50. All are positive, that means all are whole numbers. So it means the given expression is a polynomial, but it is not a polynomial with one variable. It is a polynomial with three variables. Why three variables? Because in this expression x, y and t, three variables are used, but all the powers are positive. So it is a polynomial but with three variables. Question number 2. Write the coefficients of x square in each of the following. We have discussed what is the meaning of coefficient. Coefficients are nothing but the numeric value which is multiplied by the variable. For example, if I will write here 7y. Now here variable is y, and with y, what is the numeric value? 7. That means 7 is the coefficient. Now same way we have to find out the coefficient of x square in each of the following. Let's take the first part. First part is 2 plus x square plus x. Now in the question they have asked, we have to find the coefficient of x square. So we will see the term which involves x square. Now this polynomial is consisting of three terms. Now out of these three terms, we have to first see the term with variable x square. So this second term is the term with variable x square. So we have written term is x square. Now with this x square, what is the numeric value? Now nothing is there, that means it is multiplied by 1. That means the coefficient of x square in this polynomial is 1. Now let's see second part. Second part is 2 minus x square plus x cube. Now again question is same, we have to find the coefficient of x square. So we have to find out the term which involves x square. So the term which involves x square is minus x square. So we have written term is minus x square. Now with this x square there is no numeric value. That means again it is 1. And here is a sign of minus. So coefficient is minus 1. The third part, it is pi by 2 into x square plus x. Now in this we have to find out the term with x square. So here first term is the required term. So we have written term is pi upon 2 x square. Now with x square we have to find out what is multiplied by x square. So here with x square we have pi upon 2. That means coefficient of this term is pi upon 2. Last part is under root 2x minus 1. Now question number 3. Give one example each of a binomial of degree 35 and a monomial of degree 100. So we have to write two examples. First is a binomial and second one is a monomial. So first let's recall what is a binomial. Binomial means a polynomial which consists of two terms, and monomial is a polynomial which consists of only one term. So first we have to write down a binomial of degree 35. Degree means the highest power of the variable. Now variables are not given, so that means we can take any variable x, y, z, p, q, r, anything. So binomial means two terms. That means we have to take two terms. We can take any variable and the degree is 35. That means the highest power of the variable should be 35. So we have written y raised to power 35 plus 5y square. Second term you can take anything, whether constant or a variable with power 1, 2, 3, 4, but it should not be greater than 35 because the degree of the polynomial is 35. So highest value of the exponent will be 35 only. So I have written first binomial as y raised to power 35 plus 5y square. For example, second I have written p raised to power 35 minus 12. Now you can see here I have taken variable 5 y, and in this I have taken only constant term. So you can write any binomial, but the degree should be 35. That means power of the variable should not be 35. Now second is monomial. Now we know monomial means one term only. That means we have to take only one term, and degree should be 100. That means we cannot take constant polynomial. If suppose I have taken constant polynomial 3, if we have a constant polynomial, then we cannot show the degree 100. So we cannot take constant polynomial. So we have to take a monomial because it is written monomial. So any variable you can take. Here in first case I have taken the value of variable as x and degree is 100. So we have to write exponent as 100 only. So first monomial I have written 41 x raised to power 100 or y raised to power 100 or z raised to power 100. Any variable you can take, but degree will remain 100 only. Question number 4. Write the degree of each of the following polynomials. First part is 5x cube plus 4x square plus 7x. Now let's again recall what do you mean by degree of a polynomial. Degree of the polynomial means the highest power of the variable. Now let's see this polynomial. Here variable is x. Now here power of variable x is 3. Here power of variable x is 2. And here power of the variable x is 1. So highest power of the variable x is 3. We have observed here highest power is 3. So degree is 3. Now second part 4 minus y square. Now in this if you will see the highest power of the variable y is 2. So degree is 2. Third part 5t minus square root of 7. Now if you will see the variable is t and its highest power is 1. So highest power of the variable is 1. So degree is 1. And the last part is 3 only. Now we know it is 3, that means it is a constant polynomial. So there is no variable, that means any variable with power 0. 3 means we can write it as 3 y raised to power 0 or x raised to power 0. So highest power of the variable is what? 0 only. So degree is 0. Question number 5. Classify the following as linear, quadratic and cubic polynomial. Now we have already discussed what is the meaning of linear polynomial, quadratic polynomial or cubic polynomial. Linear polynomial means a polynomial with degree 1. Quadratic polynomial means a polynomial with degree 2. And cubic polynomial means a polynomial with degree 3. Now let's see the parts of this question. First part is x squared plus x. Now we will see what is the highest power in this polynomial. Here power of the x is 2 and here power of the x is 1. So the degree of the polynomial is 2 in first part. So it is a quadratic polynomial. Second part, x minus x cube. Now in this polynomial highest power is 3. So the degree of the polynomial is 3. So it is a cubic polynomial. In third part, polynomial is y plus y square plus 4. Highest power of the polynomial is here 2. That means degree of the polynomial is 2. And when degree is 2, it is a quadratic polynomial. Fourth part, polynomial is 1 plus x. So here highest power of the x is 1. That means degree of the polynomial is 1 here. And when degree is 1, it is a linear polynomial. Fifth part, polynomial is 3t. Now variable is t and the highest power is 1. So the degree of the polynomial is 1 and it is a linear polynomial. Sixth part, it is r square. Now r square means the value of the exponent is 2 and it is only one exponent, one variable is there, that means degree of the polynomial is 2. So it is a quadratic polynomial. Last part, polynomial is 7x cube. Now here the highest power of the variable is 3. That means degree of the polynomial is 3. So it is a cubic polynomial.